we're going to look at inverse function domain and range. This time we're going to be looking at a quadratic function. Okay, and I want you to think of this as a word problem again, and this is the profit in terms of the amount of units we produce. Okay, so X is our units produced, P is our profit, and everything's going to be in thousands. Okay, so we have some function that looks like this. Right? It's facing downwards, and it has a max profit at some point, our vertex being our maximum profit. And if we sell a certain amount of units, we'll max out our profit. Okay, and we'll do a graph of that. What we want to also find out is, can we figure out if I want to make a specific profit, if I want to build a certain amount of units, how much profit will I get, and vice versa. Okay, so we'll find the inverse of this function to start. It's the same idea as I'm going to change this into a y, okay? Because essentially that is our, when we're graphing, our p at x is our y. And this still stays as x minus 5 squared. And we're going to change the position of our x and our y. So here's our x, it's equal to negative, and here's our y. Now because it's quadratic, it's a little more intensive finding the inverse. What would be the first step? What would I do?
You would take out the 10.
Yeah, and when it comes to the other side, what will 10 become?
X minus 10.
Yeah, x minus 10 is equal to negative y minus 5 squared. Now this part can be tricky. What do you think the next step would be in this case?
You would square root the whole thing.
Okay, yeah, it definitely looks like that, but there's actually a negative here. And that negative represents a -1 multiplied by everything, and it's kind of outside of this.
So you just use distributive property.
Yeah, but this time what we're trying to do is move our -1 to the other side. So because it's multiplication, when I move it to the other side, what operation will we do? Well, if it's multiplication, we would divide, right? Yeah, that's okay. I caught you off guard there. So then when we divide by -1, all that really does is change the operations in front of these. So this becomes -x and this becomes plus 10, okay? Is equal to, again, y minus 5 squared. Now, what did you say was the next step from here?
Square root it.
That's right. We would square root both sides, okay? So we square root both sides, and we're going to get the square root of -x plus 10 equals
Y
minus 5. And then what does it become in the end?
It would be square root of x plus 10 plus 5.
Plus 5 equals our y. Now, I want to rewrite this in my function notation. And remember, my original was a p at x, right? And a lot of times they would say p to the power of -1x. But what's happened now is this here essentially represents our new profit. This is our p.
So it would be x.
Yeah. So we're looking at now, which is better represented, is our x. So I guess I'll write like this, x with p as a function in it. And this is the equation for it, the root of negative, and we use p plus 10, okay, plus 5 on the outside. So what this is saying is if I want to figure out how many units it's going to take me to get maybe 300 in profit, I would plug 300 and solve, and it would tell me how many units I need to build. Where vice versa, if we're solving for profit, we plug in a number of units and we figure out how much profit we make. Okay? So if I wanted to build 1,000 units, how much profit would I make? Well, what if I want to make $1,000? How many units do I make? That's what the inverse function is finding in this. Okay? Now, let's talk about the domain and range. We'll quickly graph this on the side, do a rough sketch. Okay? Essentially, this is facing downwards. It's positive 5, so our vertex is at 5 and 10, okay, so we'll say it's about here, and it's heading downwards, okay, and we know it's continuous. So with that being in mind, I'm going to write the two functions out. P at x is -x minus 5 squared plus what? Plus 10, okay, and then x at p is equal to the root of -p plus 10 plus 5. Okay, so for our first one, which we'll do in red, our domain of this function, we'll do the rough sketch again. Okay, the only thing that'd be really important for this is technically our x-intercepts. So we should try to find x-intercepts, but because this isn't a practice in x-intercepts, I'm just going to graph it to help us with our domain and range. On your part, you would actually go and find the x-intercepts. Okay, so this says negative x plus 5 squared plus 10, correct? Y equals, sorry, plus 10. There it is. Let's zoom in a little. We'll find our function. There it is. Oh, did I have it as plus 5 on the other one?
I think so.
Oh, silly me. Oh, no, I had it minus 5. Sorry, I wrote it. Wrote it wrong. Good. Good. There was a mistake. Okay. So this being our max profit and our x-intercepts here. Okay. So I want you to think of this in terms of a company. And this is a difficult concept. We have a y-intercept of negative 15. So what this means is if we produce 0 units in thousands, we would actually make negative $15,000. So if this company produces nothing, it's losing a lot of money. It breaks even here if we produce 1.84, and now that's in thousands, so that's actually 1,840 units. It would make $0. Anything above here is positive. Its max profit is if it makes 5,000 units, it makes $10,000. And then the profit starts to dip again. Okay, and these are kind of called economies of scale. We don't have to worry too much about that yet. But we notice if we make 8,160, we're back to 0. And if we make more than that, we start losing money again. Okay? So we could never technically make 0 or less than 0 units. But we could continue to make more and just lose money. Okay? So in terms of a domain, we would technically start here and then go down this way forever. You obviously wouldn't want to because of our break-evens in business, but it is a possibility. So when we go to write the domain, okay, so the domain of our original profit function, okay, it is XER such that x is greater than and equal to 0. Right. Now our range is a little different. Because it's continuous, we have YER. And what was the top of ours?
5.
Yeah. So y is greater than, sorry, y is less than.
And equal to 5.
And actually, I don't think it's 5 because our vertex stops at 10 there.
Right.
Yeah, so we're thinking of that is 10. Okay. So instead of trying to figure out our new domain range for our inverse, we just know that these two values have been flipped. So our domain is XER, but we take this part of it such that x is less than and equal to 10. And our range, and we'll show it, I'll write the actual function in our graph there, such that y is greater than and equal to 0. Okay, so to prove that, we'll write our function in. Hopefully you can help me remember it here. Actually, I'm just going to invert these values. So I'm going to say x is equal to negative y minus 5 to the power of 2 plus 10. Okay, and if you notice, here's our functions. Okay, our domain. Oh, because our domain is a little funny here. Technically, yeah, our zeros are our stopping points. Okay, and it only exists within this range. Okay, so we would build units, and if I build 5,000 units, there's essentially two ideas here. I can make a profit of 2,000, or I can make a profit of, of 7,000. But the best is I make profit at 10 by building 5,000 units. Okay.